Let's practice graphing a cosecant function together. For this example, we're going to have the function f of x is equal to 3 times cosecant of the quantity of x minus pi minus 4. And then this is our general formula that lets us know what kind of transformations we're going to have here. In this case, we know that a is going to be 3 here. This is going to be multiplied by cosecant of what? Let's see. I think b is just going to be 1 in this case. It's going to be 1 multiplied by x minus c, but in this case, c is going to be pi. Go ahead and put a parentheses and a bracket. And then for d, it's going to be plus a negative 4. So that's going to be the value of d. Here's a, b, c, and d. Because a is equal to 3, we know that we're going to change the shape of this graph just a little bit. We're going to stretch and shrink it. The b value of 1 affects the period, but in this case, because it's 1, it's not going to affect the period at all. Because c is equal to pi, that means we're going to be moving to the right pi units from the parent function. And because d is equal to negative 4, we're going to translate this whole function down 4 units. Now, even though the period's not going to change for this particular function, let me show you why. Remember that to figure out the period for a cosecant function, it's going to be following that formula of 2 pi divided by b, but in this case, b is just going to equal 1, so we take 2 pi and divide it by 1. That's just going to remain the same as 2 pi, so no effect here, but that's why. Alright, so now that we know a little bit more about the function, let's see if we can make a table together so that we can actually graph it. To help us make a table, let's go ahead and see which function we're dealing with here. Out of the 6 different trig functions, we're dealing with a cosecant function right now, so let's just ignore everything else. When we find cosecant of theta on the unit circle, that's always going to be the ratio of the radius of the unit circle to the y-coordinate at that point on the unit circle. We can go ahead and simplify that to saying it's just a ratio of r to y at that given angle measure. Now let's take a look at the unit circle to help us come up with some values for our table. Let's go ahead and start off with 0 radians. So 0 radians is right over here. Let's go ahead and put that in our table for our x value. And what is the ratio going to be? Well, the ratio, as we said earlier, is going to be the radius over the y value. Now, keep in mind the radius is always equal to 1. So we're going to have this ratio of 1 over the y value at this location. Now the y value here is 0, so it's going to be 1 over 0. Now 1 over 0 is undefined since we can't divide by 0, so that means we're going to have an asymptote here. Next, if we take a look at the angle measure of pi over 2 radians or 90 degrees, let's go ahead and put pi over 2 in our table. That's going to be the angle measure. Let's go ahead and see what the ratio of r to y is going to be here. Now, r is still going to be 1, so let's go ahead and put a 1 here. And y here is going to be, let's see, it's going to be a 1. So 1 over 1 is just going to equal 1. So at pi over 2, the y value is going to be 1. Next, if we take a look at pi, that's going to be our angle measure. That's 180 degrees. That's a full pi. Now again, our ratio here is going to be r to y. R, as we said, is always going to be 1 because that's the radius of the unit circle. And then y here is going to be 0. So we have 1 over 0, which is what we got earlier, and that's undefined. So we're going to have another asymptote here. Next, we have the angle here of 3 pi over 2. So I'm going to go ahead and write that in. That's going to be 3 pi over 2, which is 270 degrees if you wanted to know in degrees. And what's our ratio? It's going to be r to y. So r, or the radius, is going to be 1. Notice how it's going to be 1 on top every time. And the y value here is going to be negative 1. So that's going to be on the denominator. And 1 divided by negative 1 is just equal to negative 1. Finally, let's make our way back around to the beginning at 2 pi. That's a full circle, or 360 degrees, okay? And so we have 2 pi here, and then it's still going to be that r to y ratio, which we already found out earlier. So we can just use that as 1 to 0, which is undefined, so we have this asymptote appear once again. All right, so now that we have a table for the parent function for cosecant, let's make a table for the function we're actually dealing with here. What we're going to focus on first is anything affecting the left and right movement or affecting the x values. And because we have this minus pi, it means that all of our x values for our parent function are going to be moving pi units to the right. So if we take this first x value of 0 and add pi to that, that's going to now be pi. Then if we take this pi over 2 and add pi to that, that's going to be 3 pi over 2, or 1.5 pi. Then if we have this pi and add pi, that's just going to be 2 pi. Next, we have this 3 pi over 2. If we add 1 whole pi, that's going to be ending up being 5 pi over 2. And then finally, if we take this 2 pi over here and add pi, that's going to be 3 pi. Next, we're going to take a look at the values that affect the y values. So we have this 3 over here, and that means that we're going to multiply all of our y values by 3. We're also then going to subtract them by 4, because they're all going to be moving down 4. All right, so if we take all these y values, first of all, real quick, I think it's good to know that if you have an asymptote, you can just leave those alone. So these are where our asymptotes are going to be. Let's just leave those as undefined because they're just going to stay where they are. Now, if we take a look at our other y values here, we have 1 here. So if you take that 1 and you multiply it by 3, that's going to be 3. If you take away 4, that's going to be -1. So this is going to be our new y value for when x is 3 pi over 2. And then over here, if y is -1, -1 times 3, that's -3, minus 4 is going to be -7. So that's going to be the y value when x is 5 pi over 2. All right, so we worked so hard and we finally found a table that we can use to graph this function. So let's go ahead and do that below. All right, so here we just labeled our x and y axis and we scaled our y axis a little bit higher just because we have this -7 in it. We had a vertical asymptote at x equals pi, again at 2 pi, and as well as 3 pi, 4 pi, and of course they're just going to keep occurring every pi units. When x is 3 pi over 2, f of x or y is going to be at -1, so we're going to plot that over here. Based on that, we're going to go ahead and sketch our curve coming upwards over here. And when x is 5 pi over 2, we're going to have a y value or f of x value of -7, so I'm going to plot that down over here. Now between these 2 points, whichever one is higher is going to be the one opening up and the one that is lower is opening down. And of course this function is going to keep on repeating, so we can duplicate this over here, and here, and here. And similarly for that lower part of the function, we can duplicate that part over here, and here, and here. This right here would be the graph of f of x is equal to 3 times cosecant of the quantity of x minus pi minus 4. And for just a little bit of extra credit, if we want to link this graph of this cosecant function to its reciprocal of a sine function, while this is the function we just dealt with, this would be the reciprocal function because sine is the reciprocal of cosecant. If we were to graph this sine function with the same transformations, the sine function would look something like this. I just think it's a nice little connection to make that these points where these two functions touch are going to be the maximum and minimum of each of their functions, where the maximum of the sine function is the minimum of the cosecant version or counterpart, and the minimums of the sine function are the maximums of the lower parts of the cosecant functions. So that just about wraps up this video on graphing this cosecant function. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.